Okay, we now introduce the concept of like radicals. By the way, this is a handout that was given in class on Wednesday. So I'm going to fill out the handout here and define the idea of like radicals. Like radicals, you'll see, is nothing more than it's it's the same thing as like terms, but given in radical form. So for example, 4x squared, 5x squared are considered like terms. And why are they considered like terms? Well, first of all, notice that the base on both of these expressions are the same. Furthermore, the exponents have to be the same as well. So when the bases are the same and the exponents are the same, we call the two terms like terms. So here's another example of like terms. Notice that the base is the same. The base is both x on both of these terms. And now the exponents are also the same, 1/3 in each case. So we're in agreement that these are like terms. Now I can take this first term right here and rewrite it in radical form. Remember, when I go from exponential to radical form, the base of the exponential expression becomes the radicand of the radical. The denominator of the exponent becomes the index. So 4x to the 1/3 can be written as 4 cube root of x. Similarly, 5 times x to the 1/3 power can be written as 5 uh, cube root of x. Again, notice that the index is going to be 3 and the radicand is x. Since we set the like terms up here, the bases had to be the same and the exponents had to be the same. The base translates into the radicand. The denominator of the exponent translates into the index. So since these are like terms up here, we're going to call these down here like radicals. So what's the requirement to have like radicals? Like it says up in the definition. Radicals in simplest form, which have the same index and contain the same radicand, are called like radicals. Now it's very important that you realize that the radicals have to be in simplest form first before you can decide whether or not they are considered like radicals. Well, let's go through the first 7 examples. All of these radicals are already in simplest form. The first pair, notice that on both of these radicals right here, the radicand is 3. It's 3 over here. And the index, since there's not a number shown here, or a number shown here, it's understood to be 2. Both of them are square roots. They have the same radicand and the same index, so these are considered like radicals. Okay, the second example. Again, the indices are the same. They're both 2, but if you look at the radicands, this radicand is 2, while this one is 3. The radicands are not the same, so these are not like radicals. The next one, the indices again are both 3, but if you look at the radicands, this one has an x squared and this one doesn't, so these are not like radicals. The next one, I got the fourth root of x and I got the fourth root of x again. The indices are the same and the radicands are the same, so these are considered like radicals. By the way, going back to the very top, do you see that the number factor, the 4 right here, and this one has a number factor of 5, the coefficients have no bearing whether or not these two terms are considered like terms. It's only they only have to have the same base and the same exponent. So when we put them in radical form, the coefficient in front of the radical, the 4 here and the 5 over here, have no bearing whether or not these are considered like radicals. It's only the index and the radicand. So the example we just did on example number 4, notice how in front of this radical there was an xy squared, and this one had an x squared y, and that doesn't matter. What matters is that the radicands are the same and the index in both cases were the same. That's why they're considered like radicals. All right, let's continue to the next one. On the next one, notice that the indices are different. The radicands are the same, xy and xy, but the indices are different, so these are considered not like radicals. Again, on number 6, it doesn't matter what number sits in front of the radicals. Just make sure that the radicands are the same. They're both 5, and the indices are both 4. So yes, again, these are like radicals. Finally, on example number 7, if you look at this number over here, it's not even a radical expression. So it's not even a radical expression. It's not even an issue whether or not these are like radicals. They are not like radicals because the second one's not even a radical. So there we have 7 examples where both radicals were already given in simplest form. Now the next 3 examples here, before at first glance you might think, well, look at this. This radican and this radican are different. One's 50 and the other one is 8. But the problem here, like it says, you got to first simplify these radicals. These radicals are not in simplest form. Notice that I can take 50 and use the shortcut method for simplifying radicals. I decompose 50 in the product of 2 numbers where one of them is the largest perfect square factor of 50, which is 25. So 50 is 25 times 2. I use property R3. Take the square root of 25 times the square root of 2. And then the square root of 25 turns out to be 5. So I got 5 radical 2. Similarly, radical 8. I decompose the 8 into the product of 2 numbers, where one of them is the largest perfect square factor of 8, which is 4, since 8 is 4 times 2. Then I take the square root of 4 times the square root of 2, and radical 4 turns out to be 2, and this one just stays underneath the radical. So now what I'm going to do, I'm going to compare these two down here on the bottom. Again, notice that the radicands are both 2, the indices are both 2. So these, even though at first glance they didn't look to be like radicals up here, after I simplify them, they come out to be like radicals. So you can't really decide whether 2 radicals are going to be, like right here, are going to be like radicals until after you simplify them down in here. Okay, the next example. I've got the square root of 8, which we just did, so it turns out to be 2 radical 2. But the cube root of 8 is not even a radical, it's just 2. So these cannot be like radicals since the second one is not even a radical. So these are not like radicals. On the third example, notice that the exponent of this radicand factor right here, this exponent is greater than the index. So this radical needs to be simplified. So I use a shortcut method. I take the index of 3 divided into 4. It goes in 1 time, and there's 1 factor of x that stays underneath. The exponent of the y is less than the index, so it stays underneath. So this radical simplifies into x times the cube root of xy. Now the second radical, notice that both of the exponents, the 7 and the 10, are both greater than the index. So I use a shortcut again. Take 3 divided into the 7, it goes twice, so that brings out an x squared. Take the 3 divided into 10, it goes 3 times, so that brings out 3 factors of y. The remainder on the x is 1. The remainder on the y, and when 3 goes into 10 is 1, so there's 1 factor of y left underneath here. There's 1 factor of y and 1 factor of x. At any rate, now I'm going to compare the 2 radicands. Notice this radican over here was xy. This radican is xy, so the radicands are the same. And then also notice that the index of this one is 3. The index of this one is 3 as well. And since the indices and the radicands are the same, these are considered like radicals. Like I said earlier, it doesn't matter what sits in front of the radicals. This one had an x, this one had an x squared y cubed. It doesn't matter when you're determining whether or not they're like radicals. Okay, So that's the concept of like radical.